Welcome back, Algebra 2 Copper Canyon. So I'm going to go through some quick examples for graphing. So in the last video I just showed you basic patterns for sine and cosine. So now I'm going to show you a little bit more with it. So let's go ahead and start off with example 1. So we're going to graph 2 sine x plus 3. So I already have the graph laid out. Like I said, it's kind of like a tape graph, and I went ahead and just prepped it. You can kind of do this pretty much on all the graphs that you're going to do for right now. So I went ahead and put my points, my key points, pi over 2, pi, 3 pi over 2, 2 pi over 2, or 2 pi. So I have all those done. The only thing I haven't done yet, I don't know if you can see this or if you noticed, I did not label my y-axis yet. There's a reason for that. Because when we start putting in extra numbers like this, first of all, it was just sine. We would have this done. We already know sine is center high, center low, center, boom, we'd have it done easy. But when we start adding extra numbers in the front or at the back, it changes some of the parameters of your graph. So let's go ahead and start off with this. You might remember from my class anyways, that when we start adding or subtracting numbers at the end of a function, all that does is that changes the shift. It makes it go up 3, down 3, something like that. So this is actually a vertical shift of 3. So what does that mean? Vertical's up and down, so if it's plus 3, is it going to make the graph move up or down 3? It's going to make it move up 3. Okay, now here's why I mentioned that. A lot of times this line here that I have going across vertically, that is, or horizontally, my bad, I have it going across horizontally. That is referred to as your midline. It is the center line or the vertical shift of your trig function. So I'm not actually going to make it look like I'm shifting this graph. It's just going to change the way I label it. So because this graph is shifting up at 3, this center line is now labeled 3. It's the y value 3. So I'm going to come over here to my graph here and just label this 3. Okay, I know it sounds strange because you're like, wait, what just happened? I don't want to like actually draw this 1, 2, 3. I just want to have my graph ready. So now instead of calling this 0, I'm going to say, oh, well, I shifted it up 3. So now the center is at 3. True, here it is. Okay, now on the original video we did earlier, it just had an amplitude of 1, right? So you might be thinking, oh, let's go ahead and label it 4 on the top and 2 on the bottom. That's up 1 and down 1, right? True. However, you have another aspect you have to worry about. Now they gave you a new amplitude. Okay? They're telling you on this function that your amplitude is 2. So you can't just count by 1. Remember that amplitude is your counter from the center line. So you're not counting up 1 and down 1. We're now counting up 2 and down 2. So you have to do the math for that as you get ready to label your trig function here. So if we're at center line 3, if we add 2 to 3, that would put this high point at 5, and then go back to your center line. If we subtracted 2 from our 3, that would put it at positive 1. So your low value here on the y-axis is actually going to be here at positive 1. So a little strange in labeling, but it saves you a lot of time because you don't want to actually draw it and then draw it again, moving it up 3. You just want to tinker around there with your y-axis when it comes to the vertical shifts and your amplitude. You want to know what the crazy thing is now? Now that I have those properly labeled, all I got to do is my sine pattern. That's how easy this is. So remember, sine starts at high or a center. Which one does sine start at? Sine is center. Just think sine, center, it almost sounds the same. I know it's C and an S, but center sine has a sound to it. So sine starts at a center point. So we're going to start this graph here as we label it. Here's the center. So center, high, center, low, center. And here is your graph. Boom. Now you're thinking to yourself, wait, that's the exact same graph you drew on the last one for the basic sine. Yeah, all sine graphs look the same for the most part. At first glance, they just have center, high, center, low, center. But the thing you're going to run into problems is if you don't know the exact labels here. So now think about this high point here. This high point is at pi over 2, but the y value there is no longer 1 like the last time. Now the y value is at 5. This low point here on the sine graph, yeah, it still looks like it's at 3 pi over 2, which it is, but the y value there is now positive 1. So it does sound like I'm drawing the exact same thing. I am. I'm using that pattern to build my graph, but you always got to make sure you relabel the y-axis based on your vertical shift and your amplitude that's here, okay? Once you get the hang of it, it's pretty fast because you're really just drawing the pattern. Center high, center low, center, right? All right, let's take a look at a cosine graph. Cosine, the one I decided to do here with you guys, is -2 cosine x. So on this particular graph, you'll notice that I did not put a vertical shift. Notice how there's nothing getting added or subtracted here at the back, but I did give you a new amplitude. So let's go ahead and start off with the center line. So right here, there's nothing there, so there's no vertical shift. Okay, which means that my center line is starting at 0. Okay, so I'm just going to put here start at 0. Whenever you don't see anything getting added or subtracted at the back of your trig function, you can just say, okay, the center line is at 0, dead center. So let me go ahead and label that now. So we are starting at 0. So boom, got the 0 there. But let's take a look at our trig, at our amplitude. So our amplitude, and watch how I do this, our amplitude here is 2. So you have an amplitude of 2. Notice that on that 2, notice I didn't circle the negative, I just circled 2. So let's go ahead and do our math with the number 2. So from amplitude, that means that it's going 2 up and also 2 below. So that's easy. If you take 0, add 2, you're going to have a high at 2. So your high point, your y value, is 2. Same thing here with the 0. If I take 0 and subtract 2, I'm going to have a low value at -2. Okay? So there's my y-axis all divvied up. Boom, I got it ready to go. Now, I haven't dealt with something yet, and it is important, but you got to stop and think about what this means. And you guys probably remember. What does it mean when you have a negative thrown in front of your function? Okay? This does have some value to it, but you got to remember what those negatives mean. Okay? If you have a negative in front of your value, what does it do to your graph? It causes a vertical reflection. Vertical reflection, a flip. Okay? So that's exactly what's happening here, a vertical reflection. Or as I sometimes call it, or you call it, a flip. All that's doing is taking your values and completely flipping them. Now, this might be a little hard to do at first, but this is how I recommend you do it. You can take shortcuts if you want. So we already know the pattern for cosine. It's high, center, low, center, high. I'm going to make those marks real quick. We got high, got a center, got a low, back to center, and then it ends on a high. Remember, it's got that kind of V shape, but you're not going to draw a V, right? Now, here's the thing. When you flip them, you have to think of opposite, right? This is currently at a high spot, but you're going to flip it. So if it's not high, it would be low. So that's exactly what's going to happen to this initial high point. It's actually going to come down here to the low, and that is no longer a point. So it does not start on a high this time. It starts on a low because of the vertical reflection. Now, let's take a look at this center point. Can you flip center? If you had something at the center and you flipped it, does it do anything really? No, it just kind of spins there on the center line. So this center point is actually going to stay center. Center is center, and you can't flip center. Okay? But let's come down here to the next point, the low point. Low point has an opposite. So low is going to flip to a high. So this is going to come up here to the top, make a point. Let's cross that out because remember that's gone now. We got another center point here on this 3 pi over 2. It's going to stay centered. Nothing's going to happen to it. Then again, remember the ending point. It ends on a high. It's got to be flipped. That's going to be flipped to a low point. So flip it. Let's X that out. And so you still have a cosine function, but you have a reflected cosine function. So this starts on a low and does this. Okay? So here we go. Let's graph it out. Starting on a low now because we reflected it. Low, center, high, center, low. And there is your cosine graph. Okay? is actually pretty common for like if you thought like a Ferris wheel. So when you get on a Ferris wheel, you don't load the Ferris wheel at a high spot. You don't like load at the very top of the Ferris wheel, do you? No, you load at the bottom of the Ferris wheel. So this would be an example of that. Like you're loading at the bottom of a Ferris wheel, so you have to reflect that cosine value, right? Get on the Ferris wheel, then it does its cycle, blah, blah, blah. And obviously when you get off the Ferris wheel, you better get off down there at the bottom of it, right? So you can kind of think of something like that in terms of reflected cosines. All right, see you soon.